Hello, and welcome back to the Cracking FAANG YouTube channel. Today we have another mock coding interview. This time it's from a master's student who is an ex-Amazon intern and preparing for a Google internship interview. He reached out to me via the Discord talking about his situation, and I offered to give him a mock interview to practice for the real thing. Joining the Discord and being an active member who contributes positively is the best way to get one of these mock interviews, so if that sounds like something you'd like, join the Discord community. A link will be in the description below. Let's get into the interview. Record. Okay, so I'm going to send you over the question now. So here it is. So I will paste it in, and there you go.
All right, so let me read a question. You are given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. And we can repeatedly make duplicate removals on S until we no longer can. Return the final string after all such duplicate removals have been made. All right, so this is the string S, and a duplicate removal means choosing two adjacent characters, for instance, B and B, and also they should be equal, right? And we remove them. So in this case, we'll remove BB, so we get AACA, right? And then the next step would be to remove the first two A's, and we'd end up with CA, which is no longer, we can no longer find any duplicate removals. Right, so I think that's the question. I have to return the final string after there are no such duplicates, okay. And right, let me ask, so are the characters in the string always going to be lowercase English letters or something else?
You can assume lowercase English letters.
All right, and for an empty out input, it should give an empty output, right?
Yep.
All right, so I don't see any other questions about the input or output. Let me think of some brute force approach or some initial approach here.
Sure.
So I will just I'm thinking of an approach using a stack. I'm not sure if it's the most optimal or not, but how would I do it with a stack would be to traverse the string from left to right. So let me write it here, ABBACA, and I have an index I. And I traverse the string from left to right and store every character I see in a stack, right? So I store A, and then I move the index to B, I store B, so on and so forth. But every time I am looking at the character, I also have to check whether the top of the stack is equal to this character. This means that the current character I'm looking at, so for instance here, this B is equal to the top of the stack. And if that's the case, it means I have a duplicate removal here, and I can just pop from the stack and move my index further. And this way, I will encounter another A, which I will not add to the stack because I already have an A on the stack. So I'll just pop from the stack and move the index, and the result should be given by the stack, the elements in the stack. However, given that it's a stack, in Python, I believe we can just return it as an answer. No, actually, we cannot. We need to return a string, right?
Yes.
So a stack is basically a list. So one way would be to pop every element from this stack. So this is the stack, right? CA. I would pop every element and add them to a string. I could concatenate at the end, so I'll get AC and then reverse it, or concatenate at the beginning. So I get CA. However, beginning concatenation takes a bit more time. So to recap this, I would just pop every element, add them to a string, and then reverse the string and return it. Does that make sense?
Yep, sounds good. Can you cut it up?
Sure, I can code it up. Just before that, the time complexity would be O of n, so linear, and the space complexity is again O of n. In case there are no duplicate removals, you'd have to fill up an entire stack with every character in the string.
Yep, sounds good.
All right, so for this, I'll need a function. Let's call it remove duplicate, and we'll give it a string, and I'll write a stack here, which is initially an empty list. I'll use a list. And for every character in S, if I have something in the stack, I have to check if it's empty or not. And the last element from the stack is equal to my character. I can simply pop from the stack, right? Otherwise, I only have to add to the stack the current character. And in the end, I'll have to pop from the stack all the elements. Or let me think here. I think there's a faster way in Python. You can just do stack And this is a list, so I think I can do something like, I think it was join, and I can join on empty on no characters basically.
Yeah.
And this might, I think if I have CA in the stack, it will read from left to right. Is this allowed in your opinion?
Yeah, that's totally fine.
All right, so now let me get really quick draw an example so I can make sure that this solution is correct. So I'll get a string from above and the stack is initially empty. Right, I take the first character, the length of the stack is empty, so I'll have to add it. Then I will move to B. Again, I check, I have something in the stack, but the last element of the stack, so the top of the stack, is not equal to the current character, so I'll have to append it to the stack. Then I check B and I see that it is equal to the top of the stack, so I just pop from the stack.
Yeah.
Then I put A in, same story, pop from the stack, then have C and then A. And then the join part will just take an empty string and, well, join the elements with an empty string, so I get a string consisting of CA. And that's the output.
Sounds good. I guess originally you said that you were going to be reversing it. Are you still going to do that, or do you not need to do that anymore?
Well, if I'm allowed to use this join method, I don't think I have to do that anymore. Okay. However, if I use the classic stack where you only have access to the top of the stack, so I had to pop elements. If I were to pop them in a string, I would get them in a reverse order, so I get AC. So then I would have to reverse it.
Cool. Sounds good. All right. Good stuff on that one. Let me paste in the follow-up if I just find where I put my thingy here. So follow-up. Okay, perfect. There we go. So I will place the follow-up kind of below where you were typing. So I guess we'll just go on to a new page. So just to avoid the confusion here. So I guess you can just scroll down and you should still be able to see that.
All right, so I'll read the follow-up. What if instead of adjacent pairs, so 2 being removed, you now want to remove k-wise duplicates? All right, this is interesting. So let's say I want to remove all of these 3 E's. Then I would end up with these 2 D's next to each other, remove them as well. Then remove the B's, then remove the C's, right? And I remove the A, so I'll only end up with, oh wait, that's not it. Right. Oh, because K is given, right? So if okay, so K is fixed, I cannot just take it dynamically. So the E's will be removed, the C's will be removed, and then the D's will remain, then the B with these 2 B's will be removed, and then all of the D's, okay, I got it. I got why the output is what it is. So using a stack in this case would not work because the stack would only allow me to look at the last element I've added to the stack.
Right.
But what I'm interested maybe is how many of these elements I have previously. So what I mean by that, I can still use the stack, but instead of just adding to the stack the element, I could somehow add how many times I've seen the element recently. So for instance, when I add the first D, I would add D1, right? This is the first occurrence of D. Then the next tuple, I'll basically be adding tuples. It's going to be E1, then E2. And when I want to add a new character, I would have to take, again, a look at the top of the stack and also look at the count. So no, first, if the top of the stack, which is E, is equal to my current element character, which is again E, if the occurrence of that E on the top of the stack is equal to K minus 1, so 2 in this case, I would have to pop that many elements from the stack, two elements. And if I do that, I think it should work. Should I go? Okay, I'll go through the example. So
no, that's fine. You can code it up. Okay. I follow your logic.
Right. The time complexity would be the same one, I believe, because you go through the elements at most twice. So that's linear, and the space again of n in the worst case.
Cool.
So let's call this remove k duplicates, and we'll have a string and a k. I'll define a stack here and go for every character in the string s. Now I need somehow a counter, right? Because I need also to keep the count for every character I've seen. So let's initialize it with 1. And whenever I want to add an element, I'll again have to check the top of the stack. If I have seen this element, I'll take the top of the stack count and just increment it. Okay, let me see what I mean by that, because it's easier if I show you. So first, if the length of the stack is greater than 0, then that means we can access the top of the stack. And we'll have to check if the top of the stack, the first character, is equal to our character, right?
Mm-hmm.
If it's equal to our character, let me take an example as well, because it's easier this way, right? So D and 1. And then I guess, okay, maybe we should have started with a case in which we don't have anything in the stack. So if the stack is empty, just add stack append the character. I'll use I guess this work in Python, these tuples. I'll use character and count, and also increase the count +1. So I add the D1, and then what I do is I check, do I have something in the stack? And let me just write some more branches here. Maybe it's easier to read. So first, if I have something in the stack, I want to check first if my current character, so E, is it equal? Not this E, so this is not here. My current character E, so I'm here. Is it equal to the previous character? So this is what this if it's doing. If it is, I only have to append to the stack. I believe count is fine because it was already increased, and just increase it again. So these these parts are pretty similar. I'll have to see how I can simplify that. If not, if they're not equal, this is plus equals. If they're not equal, that means I have to add a new character. So count will be reset to 1. And I'll append to the stack the new character and with the count of 1. I might not even need count at this point, and increase count again. This is not the best way of using the counter here. So let's try and simplify this or make it more readable. If the top of the stack is equal to the character, that means I can append whatever the top of the stack was. So let's call it previous count was stack of -1 and 1. And as count here, I'll just append previous count +1. Does this make sense?
Yeah.
Right. So, and I don't need count here. I'll try and not use the counter if possible. If you encounter a new element, this being said, is this case. So you have something in the stack, but you have a new element. I'll only have to append 1 because it's a new element. And if I don't have anything in the stack, pretty much the same thing, append 1. Now, there is also a case which we did not treat yet, is when I pop elements from the stack. So let me get to this with the examples up to here. So you add E1, and then you have to add another E, and you check, okay, do I have E on the top of the stack? Yes. So I take the previous count, which is 1, and add E2 in, right? And this is where we have to check, do I add E3 as well? Well, no. So before here, the previous count, if previous count, this is no longer so readable. If it's equal to k-1, I'll have to pop from stack. Otherwise, just append the next, just append the next occurrence of the character in its count. So what do I mean by pop? While I'll just use a for nothing, I'm not interested in the index, in range k-1. This is how many pops I need. Stack.pop. So in this case, I would encounter E again. The previous count would be 2. Is it equal to 2? Yes. So I will pop how many times? 2 times. So I'll pop these 2 elements out and move on with my life, right? That's about it. Oh, it's not done yet. We have to finish the function. So whatever I have left in the stack, I'd have to process it and only take the characters from it. Again, I'm going to ask you, am I allowed to process this stack as a list, or do I have to treat it as a stack now?
Well, I mean, you used a list data structure. You didn't specify that you were going to be using some stack one, so you should assume that it's a list.
All right. So this means I can simply do a processing. So stack characters would be, I'll use this Python feature for element for tuple. Let's call it for character nothing in stack. I'll just take the characters from it and then return, I think it's again join of the characters. Oh, not characters, it's stack characters. Right, so this would take the stack elements, so the tuples, and only select the character from it, so the first element in the tuple, and then store them in this stack characters list, which I then join using the empty, it's not even empty, the nothing character.
Cool.
Right. Normally, I would take another example just to make sure it works, but I think I took someone coding it up. And I would also look over it again. So what do you say?
Yeah, that's fine. I think you were doing it as you go. So I am fine with that one. So let us now, I guess, go to the second question. And just heads up, you've used up 15 minutes. So I guess we are ahead of schedule, which is good. So let me go find my question again. Where did I put that text editor? Okay, perfect. Here we go. Okay, here it is. So I will paste it again at the bottom on a new page, just to keep it clean here. And there you go.
All right, trees are my favorite subject. So given the root of a binary tree and the value of the target node target and an integer k, return a list of the values of all nodes that have a distance of k from the target node. So I'm given the root of a binary tree, so this is the binary tree, and a target node, so 5. Okay, I highlighted here. And an integer k, which is 2 in this case. I want a list of all the values, the list of values of all nodes that are k distance apart from the target node. So because k is 2 in this case, we have 1, 7, and 4. Because 3, 2, and 6 are at a distance of 1, and 0 and 8 are at a distance of 3. All right, yep. This is interesting. Okay, let's see. So I have is this a binary? It's a binary tree. That's clarified. Let me think. We do not have a pointer to the target node. This is just the value, right?
Yes, correct.
All right. So that means we would ideally have to find it first. But if we find the target node, so I would have to run a DFS or just a tree traversal to get to 5.
Mm-hmm.
And once I have 5, I would have to start from it and go k distance to all of its neighbors. And when I say neighbors, I mean its children, right? And also its parent. So I'm going to ask you, so what is the structure of a node? Should I define it?
So a node will be structured as it will have a value and an optional left and right child. You do not have access to any pointers, parent pointers, sorry.
So I would not be able to modify the node and add a parent pointer.
No.
Right. Okay, because if I had that would just be easier to start from this node and just do a breadth first search.
Yeah.
All right. So if I'm not allowed to do that, let's see. How do I compute the distance between 2 nodes?
It's just the number of hops it takes. So from 5 to 4, we see that there's 2 nodes, right? So it's 2 and 4. So that is a distance of 2. So basically just how many hops it takes starting from, I guess, 5 to get to, or how many times until you've done 2 iterations.
Mm-hmm. Okay. Yeah, I was asking it as a more rhetorical question for me to figure out. Okay, but let's see. So if I simply do a traversal, I could keep a flag if I have found a node or if I have not found a node. And understanding the distance from the children or sub-children and so on and so forth from 5 is easy because once you pass 5, you can set a flag to true, and then you just iterate over all of its children and keep track of how deep these children are from the node, target node. Yep. And if you encounter a distance of k, you can even stop and just store the result. However, it's more difficult for the parent because you cannot go up, right? Or in other subtrees, for instance, in this case, 1, 0, and 8. So this is the difficulty I'm facing. Let's see. If I do it, how do you call it? Bottom up or in a post-order traversal, coming from downwards to upwards. How would that help me? What if I'm at node 3, I know that I found 5 so far, and I know what's the distance between 3 and 5, which is 1. And using this information, I can go visit the other subtree and just increase 5. That would help me, but how can I do that? So when I have 3 problems, I usually think of the base case for one single node, and I start from the leaves.
Mm-hmm.
So one check for every node is, okay, is the current node equal to the target? If I use the flag, I would just set it, but so it would be easy if for a node, for every node, I could just take a look on the left side, take a look on the right side, and the return statements, the return results of those calls would be how far apart is the target. If you didn't find the target, it's going to be -1. If you found it, it's going to be how far apart is the target from the current node. So in this case, 5 would be 0 because, well, 5 is the target. For 3, it would be 1. And then when you go to a child, you have to kind of pass that information. Okay, I've seen the target at a distance of 1, so I'm gonna pass it to you that you've seen this at the distance of 2.
What if instead of trying to, I guess, pass all this information across multiple levels, parent and child, what if, the problem that you have here is that you don't have access to the parent, right? Because if you had the parent, then you could easily just, traverse down. What if you actually took this tree and represented it as a graph, and now you have bidirectional edges, and that way you can go from whatever your current node is to its parent and then go further, right? That way you could go bidirectionally and you would get around your problem. If you could just figure out some way to represent this tree as a graph, then you could do what you originally said, which was, go to the parent and then continue the search from there. How does that sound?
Oh, right. So I was thinking about it when I asked about modifying the node. So you said I cannot add a parent pointer, but it doesn't mean I cannot add an adjacent data structure, which tells me for each node who is its parent, right?
Correct. Yeah, you can't modify the original node, but if you want to create a graph data structure, that's totally fine, as long as you don't, modify the nodes themselves.
Mm-hmm. Okay, well, that would work. So I would have to traverse the tree using a simple, let's say, breadth first search. And for every node storing a hash map, its parent, right? The key would be the node, and the parent would be the value would be the parent. And then I would only have to start from 5. Also, okay, what if it's adding to the hash map I mentioned previously with parents? I would also add the children. So as you said, this would be the outgoing edges. So for 5, I would have obviously 62 as outgoing, but also 3 because it's its parent.
Yeah.
And then for 3, I will only have its children because it has no parents, so 5 and 1.
Yeah.
Okay, and if I have this graph, I'll have to start from 5 and simply do a breadth first search and stop once I hit, or actually do a breadth first search, and when I hit the level K, I'll return the Q because I'm going to use the Q. So for this, I need 2 parts. First, building the graph and then traversing the graph, right?
Correct.
So I'll start with building the graph. This is a simple traversal. I could do it iteratively because I think it's better from a memory perspective.
Yeah, that's fine.
Should I start coding?
Yes, please.
Right. So let me just, should I define a node as well, or is it given?
No, it's fine. Yeah, I told you what the structure was. You can just, it has a value and a left and right pointer. If you want to, if that helps you, that's fine, but don't feel like it's necessary.
Okay, so this will be the main function. I'll have to create a graph, which will basically contain the outgoing edges. I think it's a better name. So get outgoing, get outgoing edges. How am I gonna do this? Okay, let's revert a bit. So let's create a graph. It's initially empty, and then I'll have to call method populate graph using a root. This will give me the graph. Oh, I also have the target and the k value, right? So also pass in these. And once I have the graph, I'll have to, oh yeah, wait, I also need the graph in here because I want to modify it. I will have to start from the target, which I also have to find first. Or no, actually I'm given the target, I can just use the graph. So,
but it's given to you as a value, not the node itself.
Yeah, but if I have the value, I can access the graph key, right? So that's directly given. So return k level distance nodes, and I'll be given. I'm gonna give here the graph and the target and the k. So these are the methods I'm gonna code up. So let's start with populate graph, which will start with a root node and the graph, which is initially empty. So if not, I also need a parent. I'm gonna try and make this recursive. So the parent is initially none, so this is parent. And I'll call this node because it's a recursive method and it doesn't make sense to call it root. So if you don't have a node, just return. Then if you have a node, if you have a parent, you want, let me use collections default dict with a list. So I can simply append to it. If I have a parent, I'm gonna do graph of node that append the parent. And if I have a left child, I'm gonna append its value. So node that left that value. Oh, and I also have to append the parent that value, right? Because I'm gonna use pointers here, value. If node that right, if I have a right child, oh, this cuts off here, I'll append the right value, right? And then I'll have to simply move on, populate to its children. So node that left, the parent will be the node itself and the graph, and then populate graph, node that right, node and graph. Okay, these method names might not be ideal. I give you that, I admit it. Okay, and once you have the graph, I can write this method, which gives a graph, a target. Okay, I'll use a queue. Let me just go down here so you can see the queue is deck. Okay, I'll use the deck in Python, and I'll append to the queue the target, right? While I have something in the queue, so this is a queue traversal, I'll also have to keep track of the depth. Now, I'll not add an additional variable, I'll just decrement k if that's okay. So while the length of the queue is 0, now I have to traverse this level. So for something in range length of queue, this will traverse the level. And once I'm out of here, I have traversed an entire level. So I'll have to pop something from the queue. Can you follow so far?
Yeah, it's fine.
Okay, so I'll pop left, which is the current node I have. And then for neighbor in graph of node, I guess I don't have to make any checks because let me think. If I'm at 5, I'm gonna see his children 6, 2, and 3 as neighbors. I'm gonna visit those, and when I'm at 3, I'm gonna see 5 as well, right? So I need to keep track of what I visited and what I have not visited. So let me just also add a visited set and make sure. Let's add it initially the target value, and make sure here to check if neighbor not in visited. It means that I can visit it. So queue append neighbor. Right, and then after the level is finished, k minus equals 1, and I can stop when k becomes 0, and simply return the queue, which will be a list. But no, just to make sure it's not a list, I can transform it to a list. So if my calculations are correct, let me check with this example. Initially, I'll have in the queue 5, and k will be equal to 2, right? I'll go through the first set of neighbors, 6, 2, and 3. And one thing I forgot is to actually visit the neighbors. Right, okay, back to here. The next level will be this one with a k of 1. I'll visit every single node here, and I think I'll get 1, 7, and 4 in this order, maybe a different order. Does the order matter? I don't think so,
no,
right?
it's fine.
All right, so then I'll decrement k, and because k is 0, the loop would stop and just return the queue as a list. Right, I think this should work. So popping left and going through every neighbor. If it's not visited, add it to the queue to visit it. I mean, also visit it. Yeah, that's fine. And start from the target, right? Time and space complexity wise, I think I should give those as well.
Yeah.
So if you have n nodes, and because it's a tree, you'd have n-1 edges. Traversing and building the graph is gonna be of n. I have to go through every node exactly once, right? So let me check.
Yeah,
you go exactly once because it's a tree. And then the second part, which is the k level distance nodes, this doesn't have a name of, I think I should have written here get. But this one, I guess it also goes through every element exactly once. It's a simple breadth first search. So it's gonna be O of n plus O of n, which is O of n. And space-wise, I'll have to keep track of all the nodes and edges in this graph, but because I have n-1 edges, it's gonna be n as well.
Yeah. I just have a quick question about your code. I guess how can I go down? So if we go down to the while loop that you run to actually go through it, you'll notice that you actually pass in the target here, which is a value, but you set your graph key as a node value. So you would never actually do anything here, because if you look up the value of a node, which is actually, in this case, right, you initialize your queue with the target. So you'll pop target from the queue, which is, I guess in our example, 5. But when you look up 5, obviously 5 is not in the graph because you put the node as the key. So you would not actually get any result here because you're using a value instead of the actual node.
Yep. Okay, nice catch. I didn't see it. To simply fix it, you can just add the value. We know that once we pass after this if check, all the node will be valid, so I can access the value. And I didn't ask, but I'll ask now, is it guaranteed that the tree will have unique values?
Yeah.
All right, so then this should work. If not, then more changes would be required. By doing so, yeah, this should work because now the key is a value, an integer, and I can simply use the target here in this method.
Okay, I think we have about 8 minutes left. I think, could you please just walk through the example that we have and just kind of verify that I guess your code will work. I guess maybe we can kind of organize it a bit so it all fits on one screen so you don't have to switch between the two pages. It might be better for visibility. If you could just push down the, here, I'll just do it. I'll just push down the actual code onto one page. That way we can, I guess, just go through the example. Is there room? No. Okay, this.
I can write it beneath the method here because this is what the first method does. It just populates the graph, so I can write a graph here and then move on underneath.
Cool.
So I'll start off with the build graph or populate graph method. I also need the tree, right? Because otherwise it wouldn't make sense. Let me get all of this. Right here. Okay. It should fit, yeah. So I have an empty graph. I'll start off with tree, which is the root. And I have the root is valid. I don't have any parent because my call is initially the root, nothing, and the graph. So I will not run this code. Then I have a left child, which is 5. So I'll map to 5. Sorry, to 3. I'll map in. I'm gonna add to this list value 5, and I'll do the same with the right child. So I'll add 1. And then I'm gonna go left and right, and I'm gonna keep set as a parent the current node, then go left. So going left means I'm at node 5. So at node 5, I have a parent, which is 3. So I'm gonna add to key 5.
This part is fine. You can just populate the graph. There's no need. This part is totally fine. Just populate the graph because I think we're Zoom will kick me off actually at 40 minutes, so we have about 5 minutes left. So yeah, let's just populate the graph. You don't have to walk me through that. That part is totally fine.
All right. So 6 with 5. I'm gonna do it this way. So I save space. For 2 is gonna be 5. 7 and 4. For 7, we're gonna have 2. For 4, we're gonna have 2 as well, and it's a list. For 0, we're gonna have a 1, and for 8, we're gonna have a 1. Did I miss anything?
I think it's fine.
4, 5, 6, 7, 8. Okay, yeah, let's suppose it's fine. So now what happens is the second method, I'm gonna start with the queue. I'll actually write it here, and the queue is initially contains the target value, so that's 5, and this is a set. So let's make more sense here. Queue and set, and it will contain value 5, right? And then what I do is I take the value 5 out of the queue and take a look at all of its neighbors, so 3, 6, 2, and visit all of them. So that means I add them to the queue, and also visit all of them, add them to the visited set. So that is 3, 6, 2. Then I'll take the first element from the queue, which is 3, take a look at its children, 5 and 1. Now, because 5 has already been visited, I'll not add it again to the queue. I'll just
Can you keep track
1.
of K as well? Because
No,
I think you're.
I just realized I didn't. Yes, so initially K was 2, right? When I went to the nodes 3, 6, and 2, I decreased K to 1. Right now I took 3 out. I'm gonna take 6 out and add to the queue. Oh, and also visit 1. I'm gonna take 6 out and add nothing to the queue. I'm gonna take 2 out and add 7 and 4 to the queue and also to the visited set. And now I can decrease K again. Now, because K is 0, this while loop right here will stop working, and I'll return the list, the current state of the queue, which is 174.
Okay, perfect. In the last 3 minutes of time, can you run your code except with the same tree with K equals 0?
All right, so K is equal to 0. This means I have to return exactly 5.
Yeah.
Right, so if that's the case, I'll add to the queue 5, I'll visit 5, and this while loop will not even run. So I'll just return the list 5. And I think it's valid. It should work, yes.
Okay, cool. Looks good. I think we're done. I think you told me the time and space complexity earlier, so I'm fine with that. Yep. And it looks like, yeah, we finished up with 2 minutes spare. So cool. Yeah, well, I will drop off the call and then I will just start a new one and we can talk about some feedback. So, all right, cool.
Thanks.
Yeah. Cool. So how did that feel?
Similar to a real interview, I believe.
Yeah.
It was good. I felt that I did well on the first question. I finished it early, and then the second question, it took me more time to think about it. But I think I did good overall. That's my opinion.
Yeah, I would agree with that. I think, I guess we'll just go through the questions one by one. So on the first one, definitely good problem exploration, which is good. Before you even started coding, you started just walking through the problem, how the algorithm would work. You asked good questions. You asked me about, is it lowercase English letters? What happens if there's an empty string? And throughout the entire question, I felt that you had excellent communication. You came off very confident. You weren't like nervous or stuttering. So that's really good. And you gave me the time and space complexity. I guess me personally, I always just give it at the end. You gave it at the beginning. I'm not obviously not going to ding you for that. But just, I think usually you just give it at the end. But you can do it in the beginning anyway. Yeah, just ignore that. Never mind. Let's see. So for the second follow-up one, your code worked and it's definitely fine. I think there is a way to kind of optimize it a bit where if instead of using a tuple, you basically just use a list where you keep the count as the first element of the list, and then the character is the first element, and then the count as the second one. And that way, you can easily just check, okay, if adding a new character, if they're the same, increments the count equal to K, then I can just pop that one element instead of having a while loop where you need to just continuously pop. I think it's just a little bit cleaner, and like it's just a lot of code and kind of hard to read and a lot of like if else branching. So if you just do that, I think it can be cleaner, but that's like a nitpick. Your code works. The time space complexity is the same. It's just more of like, if you want to like hyper optimize these things. So that was the first question. Overall, like you said, really good, really confident on that one. The second one, yeah, you're right. You did kind of take little bit of a while to figure that one out. I think that I did have to give you a hint on that one. I think that you're kind of going down the wrong path. I mean, maybe you could have gotten to a solution the other one, but I think this is one where you do want to convert it to a graph. Um,
Mhm.
so I guess, I mean, depending on the interviewer, they may want to be an asshole and be like, I gave them a hint, which basically told them how to do it. That may fail them. Again, it's interviewer dependent. But yeah, just know that with these questions, when you kind of want that parent relationship, then you can usually just represent it as a graph, and that should be fine. Let's see. You did ask me about the structure of the node, which was good. You asked about duplicates, but at the end, ideally, you ask all the questions at the beginning,
Yep.
so you don't go back. Because if I wanted to, I could be like, oh, well, there's duplicates because you didn't ask me about them. Ha ha ha. Rewrite all of your code, right? So you definitely want to ask them at the beginning, instead of like, oh, at the end, like, what can I do this? Can I do that? Because that's just shows that you didn't scope out the problem correctly, and you can get dinged for that. So just a heads up there. Let's see. I think overall it was fine. I think for me it was a bit weird how you populated the graph doing it recursively. Initially you told me you were going to do it iteratively, which is fine. But an interviewer, they may be like, oh, I want it iteratively. So if you know how to do it iteratively as well, that's good.
Yep.
But yeah, otherwise it was fine. I think you got the right answer. I would definitely go on LeetCode. This is, I think, nodes k distance away or whatever in a binary tree. Just put your code in there, make sure it actually works. There was a few points where I was kind of like, does this work? I was a little bit like, okay, I was following, and perhaps there might be some cases you missed, but I'm not sure, because you actually did it different, Lynn, for me. So I wasn't
Yep.
exactly following that. So I would just double check that this actually works, just in case like you get this question and then you think that it's right, but it's actually not. But yeah, overall, really good. Your communication was excellent. I like how you basically walked me through your thought process at all times. You didn't really have any, sitting there in silence and coding and not telling me what you're doing, which was good. You asked me questions. You kept me engaged as the interviewer. You asked me, okay, can I proceed coding? You told me the time and space complexity without me asking, which is really good. You did the same thing for walking through examples. So
Mhm.
that's really, really good. I guess let me stop there because I just threw a bunch of information at you. Do you have any questions for me?
Right. I was gonna ask you, why do you think we should give the time and space complexity at the end? Because in my opinion, how I see it is that before coding up a solution, you should know what its time and space complexity is, so you know if this is a worth coding solution or you need to find a better one, right? If you give it at the end, then you might realize at the end, oh, but this is inefficient.
Right. I mean, yeah, that's definitely true. I mean, your interviewer will generally know what the optimal solution is. So if you kind of present one that isn't that, then it's more like they'll ask you, okay, can you optimize this a bit? But yeah, either way is fine. I just do it at the end. I've never been penalized for it, but yeah, I guess it's personal preference. Just I guess ignore me on what I said,
Okay.
because I guess it doesn't matter too much. I guess, but yeah, they'll tell you if your solution isn't optimal enough. So yeah.
Yeah.
I mean, sometimes like you only know the brute force or like a less than optimal one. So yeah. Anyway, yeah,
Mhm.
that's totally fine. You can ignore me on that point. That's just like a minor nitpick. But yeah, I guess not relevant.
Right. Other than that, I don't have questions. I just wanted to thank you for this, and let's hope I'm gonna give the same. I'm gonna do the same in the real interview.
Yeah, definitely. I think, yeah, I mean, you know how the structure goes. I think you're quite confident and able to talk through. I think the one thing I would just warn you is that obviously you said you have Google coming up, right?
Yep.
They tend to ask pretty hard questions, and then they want generally the more optimal solution. So hopefully, just practice all the questions in their list, and hopefully don't get caught out, because I think that's the one thing that makes people panic is they get a question that they've never seen before, or they realize
Hmm.
they don't know how to solve optimally, and then they start
Yeah.
panicking.
Hmm.
A lot of the times with Google, especially, they don't always need you to have the best one. I think as long as you just answer the question and they can follow your thought process and you communicate clearly and demonstrate good problem solving ability, that's so much more valuable for them to evaluate your skills as like, did you memorize the crazy dynamic programming solution? And if you
Hmm.
didn't,
Yeah.
then you fail, right? Like they want to evaluate you as an engineer and how you're able to think through problems. So, if you get one where you don't realize it immediately, don't panic. Just do what you can and then optimize with the interviewer. And it's more of like a back and forth conversation as opposed to like, oh shit, I'm screwed, right?
Yeah.
Cool.
Yeah.
So yeah, if you don't have any more questions, I think we can just end it there. Otherwise, yeah,
Yep. Thanks again so much.
cool, no problem. And best of luck in your interview. I hope you pass. Let me know how you do.
Sure thing. Thank you.
All right, bye.
Have a
Take
nice
care.
evening. Bye bye.
You too.